Okay, here we're going to take the derivative of arcsine. So what I'm going to do is I'm going to write down something like the derivative, I guess x, of arcsine. Now we're going to be using an awful lot of what we've been doing the last couple days. Remember that -1, that's not an exponent, right? This is a little awkward. So what I'm going to do is write y equals, at least I'll have an equation then. I'll write down y equals arcsine of x. Now what I'm going to do is take the sine of both sides. When I take the sine of the left-hand side, I get the sine of y. When I take the sine of sine inverse, I just get x. Now before we take a derivative, what I'd like to do is try to understand what's going on here. Remember, this is a sine. If I'm thinking in terms of triangles, this is one of the few times we'll use triangles. What we do is we take sines of angles of right triangles. So what we actually have here, if I think about it, I have a right triangle like that. Y is actually the angle here. And sine is the opposite over the hypotenuse. So I'm going to rewrite x as x over 1. That's going to make this x. That's going to make this 1. And then I use the Pythagorean theorem to get the square root of 1 minus x squared right there. Now, that's great. What I want to do now is take the derivative of both sides with respect to x. Hopefully I have enough room here. If I don't, I'll erase something. The derivative of the left-hand side. The derivative of the left-hand side. Let's just say, write it like that. What do you think? All right. Now, the derivative of the right-hand side is really easy. I just get 1. The derivative of the left-hand side, now how am I supposed to do that? That's not sine of x, that's sine of something very complicated. That, in fact, is the sine of blob. The derivative of the sine of blob, we know how to do this, right? This is the cosine of blob times the derivative of blob. And now you can see how starting this with an equation really paid off now, because I now have an equation with the derivative I'm looking for. And all I have to do is divide both sides by cosine y. So I'm going to write down y prime is 1 over cosine y. Now, I can do something horrible here. There are whole sections of trig books where, probably every trig book, where if I plug an arcsine in here to simplify that, but we've already done the prep work. Instead of actually trying to use this here, I'm going to use my triangle, because all this is asking for is find the cosine of y and put it in the denominator. Well, the cosine of y is going to be the adjacent over the hypotenuse. Well, the adjacent over the hypotenuse is just the square root of 1 minus x squared. So what I'm going to get right here is just 1 over the square root of 1 minus x squared, like that. And now we can see it. By the way, you should see a miracle here. We started with sine, which is a trig function, periodic, has lots of derivatives. We took its inverse function, we took its derivative, and all the trig is gone. It's a very strange thing to happen. A similar thing happens, however, with e to the x. When you take e to the x and you take its inverse function, you get ln of x. When you take the derivative of that, you get 1 over x. And if we were a little cockeyed, we might think that means that sine and cosine and e to the x are all related, and in fact, they are, but that's for another course.